Hello everybody, let's understand another problem that we have here. The minimum cost path with the edge reversal. It's a very easy question, right? You don't need to be surprised what we have given. I think many times I have solved this problem in the our contest video. Just little changes are there that you will understand, okay? Let's understand what we have given. We have given a directed weighted graph with n nodes we have given, and it is level from 0 to n minus 1, means it is a 0 indexed we have given. Okay, you don't need to convert from 1 index to 0. Then we have given an array edges where each element of the edge contains a node ui to node vi, with we have given the cost w. Okay, so each node ui has a switch that can be used at most once. This is very important. Okay, so whenever you are talking about a node that is u, there is a switch. Either you will use or you will not use. But if you are not using, doesn't matter. But if you are using it, you can use at least one time. Okay. Now you are arrived at u and you have not used, right? So let's suppose my ui, you have arrived, but it is not used. Means you have a chance to activate it, right? So you may activate it one of the incoming edges, either for vi to ui, or you will do the reverse thing, right? Immediately it will traverse, means oppositely it will happen. Now return the minimum total cost, that is travel from node 0 to n minus 1, and it is not possible, return minus 1. So in the very first, if you pause this and you will understand the question, right? You do it, otherwise let's continue. So what the question is saying, that you are given a directed weighted graph and you have to keep moving along a normal edge from where u to v, right? And its cost is nothing but w. That is understand. So each node u has one switch, right? It is saying there is only one switch we have given. So if you arrive at u and you haven't used it, u switch yet, you may pick any incoming edge that is called from x to u. That is, it is saying, correct? And you have to, let's suppose any node you are picking, right? Incoming edges. Now you flip it. Either you are talking about this or you're taking any one, u to v and v to u, anyone, either x we are talking about, right? Immediately it will traverse, right? If you are moving rightward, right, you have to move back, right, like that. So you have to pay the cost 2 into wi when you're doing that, right? Means double the original edge width that we have given here. If you're reversing, the reverse cost will be double. So you can do this at most multiple different nodes along your journey. So each node at most once when you arrive there, right? So means our goal, what we have given, the minimum total cost to travel from 0 to n minus 1. You can do this multiple times, the reverse thing, right? But the cost will be get increased because 2 into w, that original was w, it is multiplied by 2, right? Means we have to find the minimum cost. I hope you understand. Nobody want to give the cost, and it should be minimum. That's fine. If it is impossible, return minus 1. Let's understand how. So this example we have given, and 4 we have given, and rest of the things we have given here, right? So if you observe this, the question is saying that what is the path we have given? 0 to 1. The cost is 0 to 1 is 3. At node 1, when you are coming to node 1 here, right? At here, right? The reverse original order from 3 to 1, right? It was from 3 to 1. If you see here, it was 3 to 1. If you reverse it, right, it will come from 1 to 3, right? If it be, we have to make the cost 2 into 2, 2 into 1. It was 1 given, right? Now it is this one. So if it become 1 to 3, means the cost will multiply. Now total cost is what? 2 plus 3. 3 plus 2 is total is 5 that we have given, right? Let's understand the code now. So I hope you understand. we have to find the minimum means Dijkstra algorithm we have to apply, right? The very first we'll define the graph, right? And then the incoming edges we'll do. If the incoming edges is enabled for the reverse, right? Then we will use that. Very first you define the graph, and incoming edges you have to define it as we have done here, right? Two things we have taken, graph and the incoming edges, means the edges that we need to enable it, that we have to do, right? Means we have to enable the reverse option, then means incoming it will become, right? We will put in the incoming. So let's suppose initially we will do it, so we will track it, okay? The incoming, let's understand, we have this edges we have given, from which we will get the u, and we will get u at 0, v at 1, and w at 2. We will initialize like this. We'll keep a pair of u and v and w for each u, right? And if you want to store the incoming for the reverse, you will do what? This is your v, this is not your u, it is v, and you do the reverse, okay? Now what you need to do, we will do the Dijkstra, okay? Why we are doing the Dijkstra? Because we have to fill initially the value in the distance, right? And we'll initially we will take the 0, because at initially we have not taken any steps, so will become 0. We'll take a priority queue, we'll assign the value in the ascending order, right? In the sorted order, right? With the two values we have given, right? Let's suppose we will, to traverse, right, we have to take the visited or not as a switch case, it is switch is used or not, right? Like that. Very first you will pull the elements from the queue, right? You will get u and v, u and cost. We'll check if u is equal to, means you have reached to the target, means you reach to the last value, right? This is your initially if u, and if you reach to this, means you have reached the target, return the cost. If not, you just need to do continue, okay? Now check the normal edges, you get the normal edges and its weight. Just check if the cost is less than the weight, you apply the weight here, means this at v, it is less than, means its value should be less, means just update with the cost, because we have to find the minimum. And then you put the next node into the queue. I know you know the BFS, right, that you will apply. Then you will check the switch which is used or not. So each time we will traverse that and we'll mark it as a true. And for incoming, we'll check all the incoming, we'll find the previous with the current, right? You will check the new cost. Similarly, you will apply these things, right? You will check the, if it is new cost is minimum, you reverse it, right? And you will add it. So whenever you find the lower cost, means new minimum cost, you will apply it here, and you will get the pair of the value, you will add into the pair on the queue. Means the minimum priority will be keep going onto the priority queue, and you will traverse it and you will get it. If it is unreachable, return the -1, okay? So this is the code we need to do, but we'll do the deep dive session tomorrow morning. I'll do, and I'll create another video. I'll put in the link in this video, okay guys? So I think you have 20 minutes. Just I'm going to upload this video, and let me know in the comment section that you understood or not, okay? Thank you guys, thank you for watching this video. I'll see you in the next one, okay?